Yes.
So 6.3 is really just an extension of 6.2, where instead of having all of those general solutions be exponentials, they can be any equation. So we're going to go through as many problems of this as we can, because very similar to 6.2, but we've got a lot of variations of what this could look like. So for example 1, we're trying to find the general solution. Remember from 6.2 that before I integrate, I want to rearrange variables to where I have all of my y's on one side, all of my x's on the other. I want to go ahead and rewrite this y prime as dy dx so that I can move those variables as well. So for this one, I'm going to divide both sides by 2 plus x, so it will be on the other side. I'll divide y by both sides so that I have a 1 over y on the left side. Now when it comes to this 3, remember that if I'm finding a general solution, I'm probably going to be solving for y at the end. So to keep it the least complicated that you can, I would keep the 3 with the x's. Any constant that you've got, I would keep with the x's. So our last step here before we integrate is just multiplying both sides by that dx. So that we've got all of our y's on one side, all of our x's on another. Now we're ready to integrate both sides. Both of these are going to end up being natural logs. So on the left, we've got the natural log of the absolute value of y. On the right, we've got 3 on the outside, but then the natural log of the absolute value of 2 plus x plus c. And I should have mentioned this on lesson 6.2, but if we're going to change that c later, and in this one we are, a lot of times in differential equations you are, so I would go ahead and label that c sub 1 so that later when you change it to be the official c, it's not as weird. So go ahead and label that c sub 1. So from here, if I'm trying to solve for y, and there are cases where I solve for c instead, but if I'm trying to solve for y, maybe I can condense some things here. If I could condense this all into 1 log equal to 1 log, then I would be able to say that the arguments are equal to each other. So first I'm going to use this property of a log that allows me to move the 3 into the exponent of the argument. So now I've got that 2 plus x to the third. And also, if I'm going to say a log equal to a log, then I need to condense my c into it as well. So remember, c is just a constant, so it's really no different if I say c or if I say natural log of c. Now that is a new c, so you could label it c sub 2 or just c. This is going to be the official one, so we can go ahead and change that there. And that allows me to condense my right side into the natural log of, since I'm adding right here, that will turn into multiplication. So I have c times 2 plus x to the third. And then finally, because I have natural log equal to natural log, that means my arguments have to be equal to each other. So I have this y equal to c times 2 plus x to the third. And that is my general solution. For example 2, we are looking for a specific solution at the end. It tells us u of 0 equals 1, but still going to start out the same way. I'm separating my u's on one side, my v's on the other, so I'm going to divide both sides by u. I am also going to go ahead and move my dv to the other side so that I am ready to integrate. The left side I have no trouble integrating, so I'll have natural log of the absolute value of u. But on the right side I do need some u substitution. So my piece of this that is stuck somewhere is this v squared. And I already have u's involved in this, so I don't know that I want to actually use another u. So if you want to use x, you can. So if we want to make x v squared, and that would make our dx 2v dv. So I'm missing the 2 that I need, so I'll need to multiply by 1/2 and 2 over 2 so that I have the 2v and v squared in there. Okay, so using my x substitution now, my v squared is x, my 2v dv are absorbed into the dx. So now I'm ready to integrate, and my integral of sine x is a negative cosine plus c. If we're wanting to solve for u, then we're rewriting it as an exponential, so my e all raised to this power equals u. And remember that my x is actually v squared, so if I want to go ahead and replace it with v squared while I'm at it, I can. This turns into kind of one of those exponentials from 6.2. So where with my c value, and if I had that c sub 1, my c value, I really have multiplying by e to the c sub 1, so if I want to move that out front and be a new c, I can. And then this one was wanting a specific solution, so since u of 0 equals 1, so that means that if I'm plugging in 0 for v, I get out 1. So I've got cosine of 0. So since my cosine of 0 is 1, I've got e to the negative 1/2 here. And then I need to divide by negative 1/2 to solve for c. Sorry, e to the negative 1/2 to solve for c, which is just e to the positive 1/2. So when I plug this back into my u equals, I've got e to the 1/2 times e to the negative 1/2 cosine v squared. So to clean this up, since both of these have the same base, multiplying here is going to turn this into addition. So my u is equal to e to the negative 1/2 cosine v squared plus 1/2. So I don't want you to get too bogged down in the simplifying of these, because that part can be kind of strange, and really the most important part is that you're able to separate the variables and integrate. So I want to do a few examples where we just focus in on that piece. So for example 3, we're subtracting this y natural log of x to the other side. I'm going to go ahead and rewrite y prime as dy dx. And this one is a little strange because when you subtract that over to the other side, now my y is on the wrong side, but it can be fixed. Now I'm at the point where, since I just have this equal to that and there's no addition or subtraction happening on either side, now I can divide both sides by that negative x. I can divide both sides by negative y. And in fact, when I do that, I can divide all of it by just a negative to get rid of the negatives here. So I'll just have a positive 1 over y, my natural log of x over x. And I'm going to move my dx while we're at it. Okay, so my integral of the left is that natural log of absolute value of y. On the right, I need some u substitution. You might notice that you actually do have something and its derivative here. Remember that the derivative of the natural log of x is 1 over x. So if I make u my natural log of x, then that makes du 1 over x dx. Which means when I substitute, I'm just going to have a u du. So I've got the natural log of y. When I integrate, I have u squared over 2 plus c, and my u squared is actually just the natural log of x squared. Okay, so we're going to stop there. So for example 4, again, separating my variables, so I want to subtract the x to the other side. Rewrite my y prime as dy dx. So then I'm moving my dx to the other side. so that now I can integrate. And for each of these, remember when you've got a radical like this, it's just y to the 1/2. So I can integrate using the power rule. So I'll have a y to the 3/2 over 3/2 equals my negative x to the 3/2 over 3/2 plus c. Well, I know that you're a boy. I know you're not a girl, but it's a bit that we're doing. You're Jessica Day in this one. Okay. Do you have any polka dots that you could wear?